Hello. Welcome back to my channel. Um, the MPLS L2VPN network. So, what is an MPLS L2VPN network with a VPLS? Yeah, MPLS multi-protocol label switching, and the L2VPN and the VPLS, which means virtual private local area network service. It's a multi-point-to-point layer 2 virtual private network service that uses MPLS to connect geographically separated customer sites. Just like you can see in the picture, these are multiple customer sites here. So geographically separated locations, site 1, site 2, site 3. So making them appear as a single local area network. So that's exactly our aim in this lab. So we should be able to make it looks like this customer is connected to this subnet, which is the same as this subnet and this subnet. They are all in the same subnet. Let's stop this one. So the VPLS emulates a large Ethernet switch using a mesh of point-to-point pseudo wires to transmit layer 2 traffic such as Ethernet between customer devices over an MPLS core network. So as you can see, this is an ISP MPLS network. So we're going to be configuring MPLS on these ISP devices, and we'll form a pseudo wire. We'll form a pseudo wire between all of these devices as well, which makes it possible for these customer sites to reach each other via the pseudo wires that we're going to be forming. So to form a pseudo wire, we're going to be using a virtual forwarding instance, which is going to be VFI. This is what we're going to be using. We're going to have an instance on each of the device of the interface facing the customer side as well. So let's get into action so that we don't take too much time. And again, I'm going to be configuring CSR1, and the rest of the configuration I already have it, so it's going to be pasted on it to save time. So now let's start. So I'm going to be covering the whole stuff for you to see this correctly, but at time to time I'll be switching to the topology if we need to make any reference to it. So I already deconfigured almost all of these configurations, so that we can start from the fresh start. So we will always go to the configurations for sure. So this is where we're starting from. So we have to show the run on this interface and maybe run on this interface as well for you to know we've got nothing on there. So show run. So show run. Give me a moment, please. I need to be sure that I'm on recording. Okay. So show run interface GI1. We have nothing there yet. And 3. We both have nothing there. So this is a router in Sydney, yeah? So we're gonna start straight away now by doing the configuration. So we're gonna start with the VFI. VFI means virtual forwarding instance. Like I said earlier, it's just gonna be the way for us to create this pseudo wire, and we can have neighbors on all of the sites, the forming neighbors with all of the sites that we're gonna be connecting together. So so it's gonna be this command. So VFI, it means VFI. Look at it. It means virtual forwarding instance. So you have to put a name, VPLS. For examples, could be anything. So I'm just using VPLS. So you can use it both manual and multi-point, but we're using manual. So when we're done with this, you have to have a VPN ID. We're using 100. And then we have to have an encapsulation. Give me a moment. So when we're done with this, then we have to have the bridge domain, sorry, 2. So now we'll form neighbor. So you can see when we put the bridge domain, the VPLS changed from down to up. So we have to put the neighbor of the loopback addresses that we're going to be configuring, you know. So we can just do that, and I'm going to configure that. I believe we don't have that. So for one, the CSR1 is 10.1.1.1. So we go for 10.2.2.2. Now the encapsulation is going to be MPLS. You could use L2 TB version 3 depending on what you're trying to design. So 10.3.3.3 MPLS. Good. So that seems to be what we need to do here. So now we have to create a loopback address as well. Set. So now we have to put an MPLS on the interface connecting to the rest of the CSR, which is interface GI/1, and we'll see if we already have an IP address there, which I believe we don't. So we do not. So it'll be slash 0, not 30. Oh, sorry, this is a mistake. So we have to put 10.1 because this the connectivity IP, as you can see here, is slash 30, 10.0/30. So 10.1. It's actually up, so there's no reason for it, no short. So just be sure that we have it configured. Oh, good. So now let's use, we're gonna be using route OSPF routing for this lab today because we're just gonna you could use BGP if you want, internet BGP. It depends on this ISP locations, like we said. But in this case, we're just gonna be using OSPF, which scales well for this. So we're gonna be networking 192.168.10.0. So this is good enough for this. And now we have to go to the interface facing the customer. Interface facing the customer. So in this interface, you don't have to put an IP address on it because it's gonna be using a different kind of connection. The aim at the end of the day is for us to be able to have an automatic, you know, you're gonna be configuring some routing protocol here, so we'll not have that routing protocol here. So but eventually the aim is for us to be able to transfer forward traffic through this network, and will automatically propagate the adjacency between all of these sites. So yeah, so let's continue. So no IP address for real. You don't need to put that, but it doesn't have IP address. So /3. So first thing you have to do is service instance 1 or 2, whatever you want. So we're using 1 here. It has to match everywhere. The type is going to be kind of Ethernet. Right. So now bridge domain as well. So in this situation, you have to know encapsulation. What do you want to use? So we're going to use default. You can use whatever you like, but we prefer default to catch all unconfigured encapsulation. Now bridge domain, put it at 2. So the configuration is done here. So you can actually do some verification by showing MPLS L2 versus circuit. They're both down now because they have no connection. Both the rest of the neighbors are still down. They're not up. There is no MPLS yet. There is no LDP. There is no LDP. You know, adjacency yet. There is nothing yet. So that's why they're still down. So when we're done with the configuration of 2 and 3, we should be able to see these guys come up. So I will not be configuring this step by step because I already showed how we configure this. We're gonna do the same on the rest of the routers. So I'm just gonna put the configurations on them real quick to save time. So you'll be seeing them come up in some OSPF adjacency will also start coming up. That's what you just seen. So for these as well. Okay, great. So you can see they are all back up. So we'll also have to do some configuration on the customer sides. So I'm gonna do number one configuration, customer side one. We'll do that later. So we make it a little bit slower. So now when you do this again, you can see they're still down, but just give you some time. They're all converging. Yeah. See, one is up actually. So just waiting for the third one. It's going to multiple stuffs. So you can see the LDP is up for this as well. So one is still down here as well. So we're waiting for one here. So if it's not gonna come up, then we're gonna troubleshoot it. But I believe it should come up. But while we're doing that, we should check the interfaces as well. If it's actually configured correctly. Oh, good. So let me do it again. Okay. So what about interface GI1? So it's not forming MPLS. Yes, that's the problem. Yes, it's up now, as you can see. Yes, they are up now. So what sometimes, you need to do a little bit of troubleshooting. Well, I should have followed the steps, but sometimes too, you have to understand that when you skip some steps, you have to find what the problem is to, get you back on track. So all I hope right now. So what about the customer side? Now let's try to configure the first one, and the rest is already going to be done. It's just a regular configuration, for the customer side. We don't really need too much. So as you can see, it's connected to E0/0. So the loopback interface. Let me do the. You can use, any routing protocol you prefer. Doesn't have to be EIGRP. Of this customer site is going to be quickly configured. I don't have to do that now because to save time. So it's just going to be the same that we've done. You see, there is an adjacency straight away because everything is actually in place. So check this as well. Same thing. Great. So everything should be fine. Show IP route. You're already getting routes from multiple places, as you can see. So now from customer site 1, which is in Sydney, 192.168.1.1. Now trying to ping customer site 3, 1.3. So let's do that. Yes, you can see it works. So let's trace it. It goes through just like you're connected, locally. It doesn't go through all of the MPLS network. But for you to verify MPLS network, you can just try to ping one. Be happening in the CSRs, the provider network. As you can see, we did not configure the EIGRP, but you actually find it there, and you can see there's a lot of going on there. So you can see that's coming from all of the customer sites, but the destination is going to be that of the multicast or EIGRP. That's what we configured basically. So now let's run a ping quickly from 1 to 3. So what happens in the Wireshark? So you can see we have all this, but when you click one of the packets, you see it's actually when going through the MPLS network. Yeah. So this is actually what we're trying to explain, and which is cool. So we can see that traffic works, and it went through the different geographically separated network, and it shows that it's actually making them look